Okay, for what we have in this particular portion, okay, we have in solving systems of linear equations. Now, whenever you have like maybe a two equation system, okay, the process can be pretty straightforward, especially if you're having just the variables x and y to deal with. But in the case of what we have for three or more equations, now the process can be rather painstaking. And normally I would like for the process to be more interactive than it otherwise is. But what I've done is I've sort of pre-packaged okay, the process, okay, and there are quite a few steps that are involved. And basically, for this particular system of equations, basically, once we start getting into matrices, you'll kind of see the pattern. But basically, for this particular system that I have in the variables x, y, and z, I'm looking at a little bit of a reduction where I'm going to have a bit of a triangular pattern, okay, that is going to be created. Okay, so you have like the first equation might be in terms of x equal to something, and then have like second equation we have in terms of y, and last equation have in terms of z, and just reducing as much as possible. And let's say that for the top equation, if I want to get this in terms of x, okay, notice we have for these three equations, we have the leading terms at 5x, 2x, and x. Now you could keep the equations as they are, but what I decided to do is that since the last equation has x and 1x, okay, what I decided to do is just interchange the positions of the first and the last equations. It doesn't affect anything that we have for x, y, and z. We still have the exact same statements. It's kind of like a little change in the permutation of how these equations are arranged. Okay, so just situating x minus 11y plus 4z equal to 3 at the top, and placing 5x minus 3y plus 2z equal to 3 on the bottom, I have this arrangement. And what I'm going to do here, so I got the first equation with x, and what I want to do is that with the other two equations, I want to eliminate the presence of x. So we have just transferring over. So you got this system of equations, and if I interact the first two equations after the rearrangement, so if you notice with the first two equations, I have the terms with x and 2x, and I want to get rid of the 2x from the second equation. And so just working with what we have with the top two equations, okay, now that which is going to eliminate the presence of 2x is going to be negative 2x. So I'm going to multiply the top equation by negative 2, and looking at distributing, we have in the rewrite, we've got negative 2x plus 22y minus 8z is equal to negative 6. And just duplicating what we have from the second equation, again I have 2x plus 4y minus z is equal to 7. And if I add the equations together, notice the x terms are going to cancel out, and we have again, so negative 2x and 2x are going to go out, and we have 22y plus 4y becomes 26y, and negative 8z and a negative z will amount to negative 9z, and we have negative 6 plus 7 comes out to 1. Okay, so just transferring this resulting equation. Okay, so upon replacing, okay, the second equation in the original system, so I got 26y minus 9z in the middle, okay, and I still have x minus 11y plus 4z equal to 3, and I got 26y minus 9z equal to 1, and now I still have that third equation to work with, and I want to get this in terms of z where I can. So first of all, we got an x term, and I want to get rid of this, and the x term that exists we have in 5x, and if I interact with the first equation, so that which is going to eliminate 5x is going to be negative 5x, and so I can multiply this first equation by negative 5, and looking at the transitioning here, so I got negative 5 times the first equation, we now have negative 5x plus 55y minus 20z is equal to negative 15. And again, the last equation, we have 5x minus 3y plus 2z is equal to 3. And now we got negative 5x and 5x will cancel out. And we got 55y and negative 3y to leave us with 52y. Negative 20z plus 2z becomes negative 18z. And we have negative 15 plus 3 comes out to negative 12. And for what we have here, okay, so the x terms are canceled out, and so we've got y and z terms that remain, okay, and so replacing the last equation with what I have here with 52y minus 28z is equal to negative 12. Again, the x goes out from both the second and third equations, and the second equation I have in terms of y and z, third equation likewise, and I want the last equation to have the presence of y eliminated. Okay, so and I'm going to interact, okay, the second and third equations. So just moving over. Okay, so we got 26y and 52y, and if I negate the y terms, well, I got 52y from the last equation formation, and that which is going to eliminate 52y is going to be negative 52y. So changing this equation, okay, where I have 26y, I'm going to multiply by negative 2, and multiplying this equation by negative 2, and we'll have, again, so I'm going to have negative 52y, negative 2 times negative 9z, that will be a positive 18z, negative 2 times 1 is negative 2, and just moving the 52y minus 18z equal to negative 12 over, and again, so we have negative 52y plus 52y goes out, and we have again for 18z and negative 18z, those will go out, so the left hand side becomes 0. However, in the case of negative 2 and negative 12, this amounts to negative 14, and 0 and negative 14 are not the same. Okay, so we have a false statement, so that means that for all of x, y, and z, we end up with no solution. Okay, now so let's suppose we're going to have a system of equations, okay, where we have in 3 variables, and okay, but we have only 2 equations in the system. So we're going to end up with parametric solutions in this particular case. But for what we have, again, for the first equation, I kind of want to get this in terms of x as the first term, and in the case of the second equation, I want it where the leading term is going to be at y. Okay, so for what we have in the case of this particular system, okay, so I want to get rid of the presence of x in the second equation. Okay, so just looking at what we have in the mix. Okay, so we got, upon taking what is present, okay, so in the second equation I have the x term to be in the form of 2x, and that which is going to take care of 2x is going to be negative 2x. So if I multiply the first equation by negative 2, and we're going to have, in the case of the rewrite, okay, so we're going to have negative 2x okay, we have minus 4y minus 8z is equal to negative 10. And again, from the second equation I have 2x minus 4y plus 8z is equal to 6. Okay, and so for what we have in the case of this particular setup, all right, so we got in this particular layout, okay, so you have negative 2x plus 2x is going to go out, and we have negative 4y plus negative 4y Okay, so this will come out to negative 8y. Negative 8z plus 8z will cancel out. And for what we have in the case of negative 10 plus 6, okay, so that is going to be at negative 4. And negative 8y is equal to negative 4, so I'm going to have that y is equal to 1/2. So going back to what we have in the system, okay, so we've got x plus 2y plus 4z is equal to 5. And for the second equation, okay, that reduces to y is equal to 1/2. Now I don't have enough tools, or in this case equations, to solve for x and z exclusively in numerical terms, but looking at going back to the first equation and solving in terms of x. Alright, now remember, we're going back to parametric equations, so the last letter or the highest subscripted term in the same variable is going to be transformed to the letter t. Okay, so just looking at what we have in the mix, okay, so we have x plus 2y plus 4z is equal to 5, and we have with y at 1/2. So if x plus 2 times 1/2 plus 4z is equal to 5, and we have 2 times 1/2 is 1, plus 4z is equal to 5. And if I get x by itself, okay, so we have 5 minus 1 becomes 4, minus 4z, and guess what? So outside of manipulating the x term, okay, well I have x isolated, y is already at 1/2, and I've used up my equations. So we have with z, and we'll have that z is equal to t. So we're going to have, in effect, if z is equal to t, we have that x is equal to 4 minus 4z, which in this case is going to end up at 4 minus 4t. Okay, so we have in the overall picture, and just kind of looking at where we started out, again, the initial attempt, okay, of eliminating x from the second equation wound up being a situation where we also eliminated z, so we arrived at the solution numerically for y. So for any values that we have for x and z, y is going to be locked in at 1/2. And with y at 1/2, again, we have for the interaction between x and z, again, x comes out to 4 minus 4z, and with z is the last letter alphabetically, and since there are no more equations where we can solve for z numerically, which could lead to a numerical solution for x, we supplied the variable t parametrically for z, and so we have for the result, we had that x is equal to 4 minus 4t, and we had that y is equal to 1/2, and where we have again that z is equal to t.